All right, so let's look at the ebook. And I'm going to hit the hot spots. Oh, I'm sorry. The geometry is the chapter 9. Basic terms and conversions is chapter 8. I'm not going to spend a lot of time on 8.1 through 8.3. I will spend some time on 8.4, which is dimensional analysis. So, with that being said, most of y'all know that there's 4 cups in a quart. There's 4 quarts in a gallon. There's 12 inches in a what? Foot. There's 3 foot in a what? Yard. Most of y'all can do that. The SI units are very basic. We'll go over that right quick. And just to bring up, just to knock some of it along your or out of your memory, get some of the cobwebs loose. SI units are what we deal with every day. And that is cups, miles, feet, pounds, all that good stuff. So, SI units, talking about 16 ounces are in what? In 1 pound. Give me another one. 5,280 feet is equal to 1 mile. 2,000 pounds is equal to 1 ton, and that's the symbol for pounds, equal to 1 ton. We don't have to do time. Time don't have a metric, but that's good. That's another conversion, but time doesn't have a metric component. It only has its own component. Time is its own little thing over here. Time is its own little world, very powerful thing. It's by itself. We just leave it alone. Let's see, what else? Give me another one. Let's see, there's, okay, how many quarts are equal to a gallon? 1 quart. There you go. And everybody knows these, all right? So what I want you to do is find the table in there. Somebody find the SI table and tell me what page it's on. It should be, just keep turning until you find it. I know the metric is first in that section. Is that, let me turn to 463. Look at it, I'll make sure it's the right one. One of them is dimensional analysis, though. I want to see which one. Yeah, that's 465 is dimensional analysis. Go to 463. I can't change the pages. 463. Yeah, those are your SI units, U.S. customary units. So make sure you know them on page 463. Page 463. And if you need to look them up on the internet, just call up SI units or call up U.S. customary units, and they'll give you a whole list. The ones I don't know, and there are some that I don't know, and that's the teaspoons and tablespoons and that crap. I don't know that. I know there's a difference between a tablespoon because I do cook, and I know there's a difference between a tablespoon and a teaspoon. But isn't it 3 teaspoons equal to a tablespoon? Is that right? Oh, y'all suck. Anyway, that's Let's see if we can Google it. That way y'all can find it if y'all need it. Because all of us have areas that we're rusty, and that's my rusty area is the tablespoons and crap. So go to Google and just pull up U.S. customary, I don't even know how to spell customary, units. There we go. U.S. customary units. Oh yeah, just get up and leave. Huh? And there they are. 1 foot equals 12 inches. 1 yard equals 3 foot. 1 mile equals 5,280 feet. You don't need the old surveying units, but I do. I got to take a test Friday, and they'll be on that test. Got dang old Columbia. And here's some units right here. What are these? No, that's area. You don't need to worry about that. I was trying to find dang old teaspoons. There we go. 1 teaspoon. No, you don't need to worry about that. But what is 1 tablespoon? There we go. 1 tablespoon is equal to what? Dang old 3 teaspoons. I told you I knew how to cook. Huh? I didn't hear what she said. Where was he? In the backyard? What? What did I say? Well, I mean, they found him that quick. He must have been somewhere close. I wasn't being funny. I was just... Huh? Yeah, I don't think he was missing it. They just saw it and just found him. It ain't like some perv picked him up or something. Okay, 1 cup is equal to 8 full ounces. So 1 liquid or 1 barrel, you don't need to do that, but okay, there's your metric. We're going to go over those in just a minute. They got some metric. No, they don't. No, they don't. 1 ton is equal to what? 2,000 pounds. 1 pound is equal to 16 ounces. 1 gallon is equal to 4 quarts. Okay, they don't have it there, but you can find different. You can hit back right here. I'm just going to show you. You can put unit, table, put a table here, and you can hit any of them, and look at there. Well, that's metric. You don't, but they got all different kinds. If you just want right here, length, there they are. Length, weight, capacity, time. Again, time, they put it by itself because it's its own thing. But there's some conversions right there. I'm not going to spend a lot of time on this because you might have a weak area like I do. My weak area would be right here. My weak area is capacity, especially when you talk about the little cups and teaspoons and stuff like that. A lot of times I don't even use teaspoons when I'm cooking. I just dang old put it in my hand, dang old. A little bit in your hand right there, that's a teaspoon. If you fill up your whole palm of your hand, that's a tablespoon. So that's the way I cook. Huh? What? What? No, I don't. I go outside and play with the hogs and pigs before I do it. Yeah, and then I stick my hands in the mud. I'm just kidding. All right, there's that. So I'm not going to spend a lot of time on that. I will spend some time on the metric conversions because metric is what everybody shies away from. So we'll go ahead and talk about that. And that's what this section is all about anyway. So let's talk about King Henry what? King Henry died what? Y'all heard that before? Drinking chocolate milk, and that's what you need to worry about. King Henry died, meters, liters, grams, drinking chocolate milk. Dang old. King Henry died, basic units, drinking chocolate milk. Of course, this stands for kilo. This stands for hecto. This stands for deca. This is your basic units. Deci, centi, and milli. Now these are your base 10 units. Now the reason I don't go on to the nano and the mica and the picas and the mino and the mino and all those other ones, there's 3 out here and about 3 out here. That's your science classes. They can teach you those. because you have to, this one from here to here is 10 to the second, and from here to here is 10 to the third, and here to here is 10 to the fourth. They get bigger and bigger exponentially. But this is just base 10. So I show this one, and then, you know, you can look, I think in the book, there's another one that shows you the nano and the peka and all them other ones, and the ones on the outside of these. Let's say we're given a metric unit, let's say like 4 meters. And they ask us to change that into centimeters. Okay? This is just like cups, quarts, except this is metric. So before we were talking about, you know, changing from standard to standard, standard to standard. That's just unit conversions. And this is unit conversions. So I find meters. Where is meters? Right here. So I start right here. And where is centimeters? Right here. So I move the decimal 2 places to the what? Right? So the decimal is right here. So that's going to be 4. And then 1, 2. So 400 centimeters. And that's how you do metric conversions. Very simple. Again, chances are you've probably seen this before. Don't believe the student that told me one time, I ain't never seen that before. My teacher taught me king helicopter drank. And I'm like, shut up. It's the same thing. Some students are just, they need a friend. I'm just going to say that. I could be worse, but they need a friend. Yeah. I better sugarcoat it. And I don't understand that, Mr. McClure. I use PEMDAS. Whatever. Whatever blows your hair back. All right, so let's do a nerd. Let's do 504,000 millimeters equals blank kilometers. Notice negative, please. 504,000 millimeters. How many kilometers is that? Well, where is millimeters? Millimeters is where? Down here. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Is 0.504 what? Kilometers. So it's a half a kilometer. Now you also need to know how many of what's or what. Well, how many millimeters are there in a centimeter? 10. How many centimeters are in a decimeter? 10. How many decimeters in a meter? You see the pattern? 10. How many meters are in a decameter? 10. How many decameters are in a hectometer? 10. How many hectometers are in a kilometer? 10. 18? No. 10. 10, 10, 10, 10, 10, 10. So how many milliliters are in a deciliter? 20. You sure? Why'd you get 100? 10 times what? 10. There is 100 milliliters in a decimeter. How many milliliters or whatever is in a liter? 10 times 10 times 10? 1,000. And that's all there is about metrics. Now, some of you have had this before because it's not like when I went to school. Let me tell you, when I went to school, the world was going to end and the United States was going to be absorbed into the metric system. Okay, because when I was going to, I remember when I was at Varenus, and I was going through Varenus, they made us remember these, and they made us say, and they made us think to ourselves that when we get to high school, there's not going to be any more SI units. Everything's going away. The U.S. system is going to be obliterated, and we're going to be with the rest of the world, and we're going to be metric system. Did that happen? No, it did not. The United States did not change with the rest of the world. Okay? The rest of the world went to all metric system. The United States did what? We stayed the same. And then it came from, everybody's got to learn this or you're going to die, to, okay, you need to learn this because you're going to see it on labels. And now it's, okay, you're going to see SI units or you're going to see metric units. So it went from one extreme to, okay, you're going to see both of them. So now it's not a big priority as it was, but now you've got vehicles, half the bolts and nuts are what? Standard. Half the bolts and nuts are what? Metric. That's why sometimes most of your cars now that are made overseas, whether they're Ford or whatever, Chevy, they're still made overseas, are made with 10 millimeter bolts instead of what? 7/16 bolts. Or 7/16 nuts, whatever the case may be. So that's why sometimes when you're changing your battery cable or your battery end on your battery and you reach for a 1/2 inch or 7/16, it don't fit because it was made overseas and it uses what? Metric bolts, which would be a 10 millimeter. 10 millimeters close to, no, 12 millimeters close to 13, it's close to a 1/2 inch, and 10 millimeters close to a 7/16. Question on that? I'm not going to spend a lot of time on this. I will tell you this. Make sure you know what meters, liters, and grams are. What is meters? What is that? Distance or length. What's this? Volume or what? Capacity. Dang old 3D, dang old milk cart. Dang old length times width times height. What is this? Dang old weight. Or mass, if I spelled weight right. Actually, mass you have to multiply by 9.8, but we won't get into that. Okay? So make sure you know that. And, you know, what would the capacity for a, and this is some of the homework test questions you might get. What would the capacity for a swimming pool be in metric? Would it be centiliters or millimeters, milliliters, or would it be kiloliters? That's not rhetorical, I'm asking you. Kiloliters. Why? Because it's biggest. And a swimming pool is not a 5-gallon bucket. A swimming pool is huge. Alright? As far as capacity goes, because there's a lot of water in it. So you wouldn't use milliliters, you wouldn't use milliliters or centiliters. In fact, if you want to know the truth about it, these are hardly ever what? Used. Those are hardly ever used unless you're just strange. Most people know what millimeters are, or milliliters. A cc is equal to 1 milliliter. A millimeter is equal to the head of a pin, pretty much. The width of the head of a pin, or head of a small nail, that's a millimeter. A centimeter, you measure a paper clip in centimeters. A lot of people don't know what a centimeter is. It's about the width of your fingernail. A meter is about like a what? A little over yardstick, like a yardstick. A little bit over a yardstick. What about a liter? A liter is what? About like a quart? Yes, Hubert. No, Hubert. I have no idea, Hubert. What does a gram equal to? Well, a gram's pretty small. Gram is what a paper clip is weighed. Grams. Def does not use, tech does not use. Kilometer. What is a kilometer? What's the first thing you think of with a kilometer? The old SI unit. A mile. 1 kilometer is equal to what? 3 point, or I can't remember. 5K is 3 miles. 1 point something, I can't remember. What about a kiloliter? A kiloliter, that's pretty big. That's pretty big. And a kilogram, that's pretty big. What would a car be weighed in? Kilogram, because it's big. And actually, people are weighed in kilograms, but we never use it. You can go home and stand on your scale. It might have kilograms on it, but it also has pounds on it. Questions on that? I'm not going to spend a lot of time on it, but there'll be more of these on the test than there will be the cups to quarts and things like that. There's not going to be a lot of these. We're going to do a lot of dimensional analysis. Dimensional analysis is in 8.4. That'll make up most of your test out of Chapter 8. So if I give you 20 questions on the test, and half of them coming from Chapter 8, then about 8 of them are going to come from 8.4. And 2 or 3 are going to come from 8.1, 8.2, and 8.3. Okay? So you might want to make a mental note of that. All right, let's look at something else. That's 8.1, metric conversion. I'm not going to spend a lot of time on that. On 8.2, that's probably going to be area, but we'll go ahead and look at it. Again, I'm not going to spend a lot of time on area because that's something a lot of you should already know about. I'm waiting for my page to turn. It's just not turning. There we go. Yeah, area and volume. I'm not gonna cover a lot of conversions with area. Length, area, and volume. This is 8.2. I'll give you a good way to know the difference between the two. Length, area, and volume. Length, I hope I spelled that right. Area and volume. Now, these two are pretty much self-explanatory, but this right here, we're going to put perimeter under it. All right? Now, most of y'all know through my information sheet that I own land surveying business. Land surveying, you know what land surveying is? Anybody know? No, that's landscaping. Anybody know what it is? It's finding your property corners and your property what? Lines. And let's say you own 20 acres and you want to give somebody an acre of land. Well, you just don't go out there and put up 4 flags and say, here's your acre. You've got to have it documented. You've got to have it deeded. You've got to have it go through a lawyer. Well, that's what I do. All right? So, most people, they go out and they get them a dadgum acre of land. And what do? The first thing they do, what do? Anybody want to, if they don't put up a house yet, but they buy an acre of land, first thing they do is they put up a fence and put no trespassing on it. That's the first thing they do. So, if I wanted to put up a fence, which one would that be? Would that be perimeter? Or would it be area? Or would it be volume? Which one would that be? It would be perimeter, because what does the fence do? It goes what? Around the property. Actually, that looks like a boxing ring. You gotta put a fence every 10, put a post every 10 feet. Because we want to keep people out of it. You know what I've noticed about people in the 10 years I've been surveying? Who puts up the biggest fences? Anybody want to take a stab at it? The people that own the least amount of what? Property. That's who puts up the biggest fences. And the biggest trespassing fine. Anyway, so perimeter is basically walking around the what? Around the figure. Walking around the shape. How is it measured? It's measured in whatever you want to measure it in. Feet, meters, most of the time it's feet and meters. Feet or meters, and most of the time in the U.S. it's what? Feet. So that's perimeter. Well, they get the fence in, and then I notice I go back out there because they want to do something else with the property line, and they done got them some cows. They're going in the beef cattle business. So they get them a couple of cows, and before they put the cows on the property, what do they got to have on the property in order for the cows to live? They got to have grass. So you get handy dandy bag of grass, and you put it all over the ground. Right? So you cover the whole piece of property in grass. All the ground. What's that called? It's called the area, because you have the length times the what? The length. You got to cover the whole area. So that's length times your width, which is area. Length times the width. And that's for a quadrilateral. But what about the perimeter? What's the formula for perimeter? Well, if you're going to walk around the property, what do you do with all the lengths that you walked? What do you do with them? You add them up, and that's the perimeter. So this is 208 feet, and this is 208 feet. Then you got 208 feet times 4, which is 832 feet. So if you wanted to fence in your property, you need to buy at least 832 feet of fencing materials. What about a circle? Well, a circle, you have a different formula, which is pi r squared. And we'll get to that later. Grass covered, all on the ground, you multiply the length times the width. Now, if you multiply 208 by 208, somebody multiply that right quick. What do you get? You're going to get somewhere around 43,560. Somebody multiply.
43,264.
Okay, 264. All right, take 43,264 and divide it by, did you say 43,264?
43,264.
Divide it by 43,560. What do you come out with? 0.993 what? 2047 acres. Each 1 acre. All right. How did I know that? Well, I've done it all my life. Well, I've done it since I was 9, 10 years old. 43,560 is how much? That's an acre. That's square feet. And you need to know that. Why do you need to know that? So you don't sound stupid when you go buy a piece of property. When you buy a piece of property, you need to at least know that there's 43,560 square feet in an acre. That way, if you ever want to figure out how many acres are in a piece of property. Let's say this is 110 feet or 100 feet on the road, and somebody else's house is right here, but you bought this piece of property, and this is 200 feet, and this is 100 feet, and this is 150 feet, and this is 300 feet, and of course this is 250, 200 plus 150 is 350. All right, so how are you going to do it? Well, basically what a surveyor does is he divides it in. This is old survey. In other words, you only got a rectangular type piece of property. This is the old way that they figured it. You take this guy, 350 by what? 100. That's what? 350, and then add what? 2 zeros. That's the area there. And then what is this guy? Well, 150 by what? 150 by 100 is 150, and then what do you do? Add 2 what? 2 zeros. So that's 35,000 and 15,000 is what? 60,000? 50,000. Somebody take 50,000 with your calculator and divide by 43,560. What do you get? 1.147 acres. 1.15 acres. And that way, when you do buy a piece of property or somebody gives you some property, you can take a tax map and you can actually use a scale, before you call a surveyor, and you can look at it and measure it. And then once you get the measurements, you can divide by 43,560, you get the area, divide by 43,560, and you know about how many acres you have. And then you call a surveyor, and the surveyor comes out there and gets it right on the money. So that way, if you're buying acreage, if you buy acreage, you always want a surveyor. What if you sell acreage? Yeah, because that's money. You don't just say, okay, I'm going to sell that. I think there's an acre there. I'll just sell it to you for 50,000. You don't sell that because it could be an acre and a half. If you're selling it for 50,000 an acre and you really have an acre and a half there, they owe you what? 25,000 more dollars. So if you ever buy property or sell property, you better make sure it's exactly, especially if you don't know the person, you better make sure that it's exactly what they say it is, especially if it's a big piece. Just call me up, I'll help you out. I'll charge you at least, though. All right? So, and then you got well, what happened to the cows? Well, they all died because they didn't know what he was doing. So they all died. So what is he going to do now? He can't raise nothing on the property because he can't. Everything dies. So he hires a backhoe or a track hoe, and he decides to make a big what? A big pond. He decides to add a dimension to it. And what dimension is he adding to it? Depth or height, depending on where you're at. If you're in the bottom of the hole, it's height. If you're at the top of the hole, it's what? Depth. Depends on where you're looking at. So, and he fills it full of water, and now he makes a big pond out of it because all the cows died because he didn't know what he was doing. And now you got a big pond. Well, now it's volume. And volume of a quadrilateral is length times what? Width, which is your area, your green, plus the extra what? Dimension times height. And that's what volume is. Volume is a swimming pool, or a milk carton, or Coca-Cola, 2-liter Coca-Cola, that's volume. Area is painting this wall right here, or painting this floor, that would be area. Length times what? Width. So if you want to paint a room in your house and your room is 8 foot tall and oops, can't draw very good. I'm not a good drawer. There. There's our room. It's 8 foot tall. It's 8 foot or 12 foot wide and 12 foot deep. Well, you don't paint the floor, do you? No, Hubert, you don't paint the floor. And you don't paint the ceiling, do you? No, Hubert, you don't paint the ceiling. Thank you for the interaction. So, you got a wall here that's 8 by what? 8 by 12. We're going to paint this wall that's 8 by 12. You're going to paint this wall that's 8 by 12. You're going to paint this wall that's 8 by 12. And you're going to paint this wall that's 8 by 12. So you're going to paint 4 walls at 8 by 12. Well, dang old 8 by 12 is what, 96? Dang old 4 times 96 is 400 square feet. Oh, I'm sorry. 4 times 96 is some kind of... Thank you. But you're going to say 400 because 1 can of paint does... I don't know. I just painted my daughter's room, so I can't remember. We got 2 cans of paint. I don't know, 200 square feet? I don't know. It was about that much. So 2 cans of paint did it. And it's about this size. I think hers is 15 by 15. But anyway, you take, if it takes 200 square feet per can of paint, then I need to get 2 what? Cans of paint to do these 4 walls. And that's why you need to know the difference between volume and area. So that way when you do go to a store or you do, whatever, you don't sound like an idiot. Oh, I got a room that's 12 by 12. Figure it out before you go up there. Dang old Google it if you don't remember it. Alright? And if you wanted to figure the swimming pool, and the swimming pool is 20 feet by 6 feet by 10 feet, then you can figure that as 10 feet by 20 feet is what? 200 times 6 is 1,200. What kind of feet? Nope.
Cubic.
Why? Because how many dimensions do you have? 3. So it's cubed. How many dimensions do you have with area? 2. So it's what? Square feet. Remember that. With your perimeter, how many dimensions do you have with perimeter? 1 dimension. Why is it 1 dimension? Because you're walking what? Around the property. Do you go up or down, or do you just go around? You go around, Hubert. That's right, class. So you don't go up or down, do you? You just go around. So that's length, which is 1 dimension. So feet to the first power. 1 dimension, 1 power. Area. Area, what do you do there? It's 2 dimensions. What is that? Length times what? You have 2 dimensions. So that means feet to the what? Second power. 2 dimensions, second power. Volume is 3 dimensions. Why? Because it's length times width times height, which is feet to the third power because you have 3 dimensions. Oops, sorry. 1 plus 1 plus 1 is what? Third power. I've shown students that before and they go, I've never noticed that. Well, at least you learned something in here, right? No yawning in class. So I'm not going to spend a lot of time. Now, do not worry about the conversions, because I don't go over the area conversions. Write that down. I do not cover area conversions. All I want you to be able to do in this section is I want you to be able to find the area of a shape. That's all I want you to do. Don't make a big deal out of it. So make sure you can handle some of these. I hate the way they have this thing. Let me put it down. There. Make sure you can do some of the problems that have to deal with finding the area of a tabletop, finding the area of a piece of property. If you've got a problem in your homework about finding the area of a piece of property, you can bet your bottom dollar it's going to be on the test. Okay, because that's what I'm partial to doing. Or the volume of a swimming pool, or the volume of a whatever. Now, what about a hot water heater? Well, that's a circle. Well, I'm going to go ahead and show you, and I'm just going to Google it because I'm not going to look for it in your book. You can look for it in your book, but I'm just going to go to area and volume sheet. All you got to do, there it is. There's your circle, pi r squared, like I told you. That's the area, pi r squared. What's the circumference? Well, what's another word for circumference? Perimeter. Perimeter of a circle is 2 pi r. Now, when you use pi, I would highly suggest that you use the pi button on your calculator. Do not use 3.14 unless the directions specify to use 3.14. Because if the directions do not specify to use 3.14, then that means that they're using an answer, the 10-digit pi, which is 3.14159723, blah, 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 blah. So if it does not specify 3.14, you need to use the pi key and use and round at the end of the problem. So there's your area of a circle, and there's your perimeter of a circle. And here's your volumes. And the volume for a cylinder is right here. Base times height. Now, it also says the what of the base. The area of the base. So that's length times width times height. But in this case, the base here is what? A circle. So you have to do what? Up here, you have to do pi r squared times the what? No, right here, the h. The height. So write that down. The area of it, the volume of a cylinder is the area, which is pi r squared times the what? Not yawn. Times the height. So the area of the volume of a cylinder, the hot water heater, is pi r squared times height. So we go back to our handy dandy problem here, and I'll just blow this up a little bit, let you look at it. You don't have to write it down because it's like not very difficult, okay? A hot water heater is in the shape of a cylindrical cylinder, has a radius of what? 50 centimeters. Okay, so that's your R. And a height of 148 centimeters. So it'd be pi r squared. 50 squared is 2,500. So it'd be 2,500 times 3, which is 7,500. And 7,500 multiplied by 148. Somebody take, I'm rounding. I know it's not the exact answer. Somebody take 7,500 and multiply it by 148. What do you get?
1,110,000.
Okay, they got 1,160,000 because they're doing it like that. They're changing it into meters. That's fine. I don't care how you do it. It doesn't matter to me. So that's how you do it. That's 8.2. .3, mass and temperature. I'm really not going to have too much on this one, except I want you to be able to say, determine what metric unit you would use to express the mass of a 1-year-old child, a box of cereal, a frog, a whale, a laptop computer. Make sure you understand what that means. I don't think we're going to measure a whale in milligrams. What are you going to measure a whale in? Huh? Kilograms, or metric what? Tons. Most of the time kilograms, because some people don't even know what a metric ton is. But most people say kilograms, but that's okay. How about a 1-year-old child? You're going to measure them in kilograms. Most people are measured in kilograms. What about a box of cereal? Grams. A spider. That would be very small. That'd be like at least 5 or 6 paper clips. So that'd be grams. Make sure you can do a problem like that. I doubt you'll see one on the test, but if I was going to give you one, it'd be one like that. I do think you need to know right here, this is important because some of y'all are medical people. 1 gram is equal to 1 milliliter. You need to write that down because some of you medical people, you need to remember that. What if you have one like this? Look at this one and tell me what's the problem with this fish tank. I'm sorry, what? I didn't hear you. All I heard was a couple of mumbles. No. That's what I heard. Enunciate, people. Huh?
Got 3 different units.
No.
Got 3 different units of measuring.
That's it. It's 3 different units of measurement. You can't do it that way. You got to make 1 unit of measure. You can change them all into millimeters, you can change them all into centimeters, or you can change them all into meters. But you're going to have to change 2 of them. 1 meter is equal to, well, I mean 50 meters, 50 centimeters is equal to, in centimeters that'd be 1, 2, so you got to change it, that'd be 0.5 centimeters or something like that, 0.05, whatever the case may be. Millimeters, 250 millimeters. Well, decimals here, 1, 2, 3, so that'd be 0.25 meters and 0.5 centimeters, or 0.5 meters, I don't know. Whatever the case may be. And then, once you change them all to meters, or all to centimeters, or all to millimeters, then you can multiply them together. And there they are. 0.25, I said 0.25 and 0.5, so that's how you do it. Now, please don't put 1 times 0.25 and then call it centimeters cubed. All right, you changed everything into meters, so it would be meters cubed. All right, if you changed everything into centimeters, then it would be centimeters cubed. Just wanted to make that little note. Has been reported for an error. Temperature. The only thing I want you to do with temperature is I want you to be able to do these 2 formulas right here. Make sure you can do them. Write them down. They're on page 458. And they are conversions. So make sure you can convert a Celsius to a Fahrenheit and a Fahrenheit to a Celsius. Celsius is metric. Fahrenheit is standard. So this is basically plug and what? Okay, they give you 20 degrees Celsius. You take 20 degrees Celsius, you need to change it into Fahrenheit. That'll be 20 times 9/5 plus 32. And if you want to do it on a calculator, knock yourself out. I'm not going to make you do it any other way. You can do it by hand. That would be 20 over 5, which is 4. 4 times 9 is 36. 36 plus 32 is what?
58.
Simple as that. So 20 degrees Celsius is 68 degrees Fahrenheit. Now, I will be glad to go over any of these questions after y'all try it for homework. But we have not hit really anything yet that is going to make y'all confused or that will make you quit your homework. A lot of stuff that we're doing right now is stuff that you did in grammar school. Okay? I usually do not spend a lot of time on this whole unit because really, I really don't think we need it. I don't. Because really it insults a lot of people's intelligence. And that's that section. I'll tell you this, out of that section, you'll probably see a Fahrenheit or Celsius question on the test. And that'll get us to 8.4, which is pretty much what's going to make up a lot of your questions on the test from Chapter 8. Make sure you can do, or make sure you know this one right here on page 465. Make sure you know that. Make sure you run a copy of it. Make sure you run one. No, do not run one off of the. Do not Google it. Why? Because some books, they say 1 inch is equal to 2.54 centimeters, and some books say 1 inch is equal to 2.542 centimeters. And then that will throw a monkey wrench into your answers. All right, so don't do that. What I would do if I was you is just use this or use the scale that's on your questions. Some of your homework questions is going to say go to the conversion table, or they'll have a conversion table right there. It'll be the same as this. But do not go to Google and Google one of these because the rounding will be different. Okay? Unless you pull it from this book on Google, the book that y'all have, and run copies of it. You can do that. It is from that book. But what is dimensional analysis? Dimensional analysis is a 25-cent word for converting metric to standard and standard to what? Metric. You're crossing the two worlds together. In other words, you're going from one world to the other. So far, we've done metric to metric and standard to what? Standard. And that's called unit conversions. You're changing from cups to quarts. You're changing from quarts to gallons. You're changing from feet to miles. You're changing from pounds to ounces, or whatever the case may be. Changing from millimeters to kilometers. You're changing from kilograms to milligrams, and vice versa. So you're staying within the system. But when you go from one system to the other, you have to use this conversion chart. Now, what I would suggest is that you make a list of things to do when you start dimensional analysis. Make sure I spelled it right. I don't know how to spell dimensional. D-I-M-E-N-T-I-O-N-A-L, I think, but I ain't going to write all that. So D-I-M-E-N-T-I-O, or I can't remember. Let me see if I can do it. D-I-M, dimensional.
That's right.
Okay, there it is.
There's no.
It's a what? Okay.
I thought it was a
There.
about the same.
I told you I got it wrong. That's why I did that. I suck. All right, now, dimensional analysis is when you go from one system to another. So SI to metric, or metric to SI. The first thing you want to do is start off with a fraction. They're going to give you a number. First thing you need to do is make it a fraction. Put a 1 over it, or they may go ahead and give you a fraction. And I'll talk to you about that in just a minute. Start off with a fraction. 2. Remember that multiplication cancels which way? When you do a multiplication problem, which way do the canceling, which way does that take place? What's that called? Diagonally, right? So, diagonal, remember that. Because the unit conversions, when you do a unit conversion, you have to set it up diagonally so that you can get the units to do what? Cancel out. 3, set up and cancel units. And 4, do the multiplication. And division if needed. So this is how we do unit conversions and dimensional analysis. Now, when you do this right in here, somewhere in here, you're going to use the table that I gave you on page 465. Somewhere in here, you're going to look at it. So let's go ahead and do one after y'all write that down. Let's go ahead and do one, and I'll show you what I'm talking about. Everybody got it written down? All right. So let's take, I don't know, let's, let me hit, and let's just go to an example. All right, let's look at this. 3½ cups. I'm going to go back here. 3½ cups. How many liters? Well, first of all, 3½ cups. How many liters? All right, you don't even look at this right now because we don't even need this right now. We got to set it up. So first of all, I'm going to change 3½ cups. I guess we need to change that into an improper fraction. You don't have to. You could just put 3½ cups over 1. You can do that. 3½ cups over 1. Okay, so now we've got to set up to where cups will go out. So where does cups need to be? On the top or the bottom? On the bottom, because we cancel diagonally. See? We cancel diagonally. Now we go to our handy dandy chart over here. And what is cups and liters? What is that? Is it length, weight, or capacity? It's capacity. So you go down to your handy dandy capacity right here and look for a cups to metric. Now notice I didn't say liters because it may not have a cups to liters. You may not. So cups to liters. Do we have a cup to liters? Yes, we do. 1 cup is equal to what? 0.24 liters. And what cancels out? The cups, and now you're left with 3 times 0.24 what? Liters. So that would be 3.5 times 0.24 liters. Let's see. That would be, hold on. That's dumb. You don't even give me a chance. I was going to try to do it. Let's see. 3.5, 10% would be 0.35. So that would be 0.7 would be 20%. And then 1% would be 0.035, which is 0.04. So that'd be 16 cents. So I'm thinking, I would say 1.6 plus 0.7, I would say 0.87. What did it come out to be? Oh, 0.84, I'm sorry. Equals 0.84 liters. Now that's a one step. So it's pretty simple, but the main thing is you can't set up your unit conversion until you do this and you get the cups to do what? Cancel out. And that's how you do unit conversions. All right, let's do nerd. And this is what Chapter 8 material, 80% of Chapter 8 material is going to come from this section. So make sure you know how to do all of the 8.4 homework. Let's see. I don't do area conversions because you don't never have to do that. All right, this says, I don't want to do that either because that's money and I don't want to do that. I want to do stuff that you're used to doing. All right, let's look at this. This is a health question. Drug dosage is often administered according to a patient's weight. For example, 30 milligrams of the drug blah, blah, blah is to be given for each kilogram of a person's weight. That's a ratio right there you start with. Write that down or circle that. If Martha Green, who weighs 136 pounds, is to be given the drug, what dosage should she be given? All right? Drug dosage is often administered according to a patient's weight. For example, 30 milligrams of the drug should be given for each kilogram. Well, then what's the problem?
30 milligrams per kilogram.
I know, but what's the problem? Why is there a problem? Why do we have to convert anything?
If you got milligrams and kilograms.
And what's the problem? Huh? What's the problem here to there? What's the problem? You got metric and you got what? Standard. So you got to do a unit conversion. The first thing you should put is 30 milligrams of the drug is to be given for each what? So that's 30 milligrams over one what?
1
Kilogram. All right, now you're ready to start your conversions. Well, I ain't got no other numbers. Well, the only other number you got is what?
130 pounds.
136 pounds, but you don't have any pounds here. So you got to do something. So you go to your handy dandy table and you look for something you can convert to pounds. And you get an error and you decide to quit. There we go. So we need what? Weight? 1 pound is equal to 0.45 kilograms. So where is 0.45 kilograms going to go? It's going to go on the top. Why is it going to go on the top? Okay, we're still not through, because what does our woman weigh? Our person, what does they weigh? 136 pounds. Where's that pounds going to go? All right, let's see what happens to our units. Kilograms do what? What does the pounds do? What are we left with? What is the medicine measured in? What does the question ask? How much medicine do you give the person? So are we done? Yes, all we have to do is multiply 30 times 0.45 which is not hard to do because that's about 15. And then times 136. I'll do the math for you right here because it's over 1. So it's basically this right here. Let's see. 30 times 0.45. If you was to do that in your head, let's see, that would be, let's see, 30. 10% would be 3. So 3 times, I think that'd be close to 15, wouldn't it? Or, let's see, 30 times, yeah, that would be 12. And then 10% would be, or 1% would be 3.3, and 5 times 0.3 is 1.5. So I'd say it's around 13.5. Somebody check it and see. What's 30 times 0.45? 13.5. Okay, so we got 13.5 times 136. Okay, 10% of, let's see, 10% of 136 is 13.6. 1% would be 1.36. So 3 times 1.36. 1.36 times 3 would be 4. I'm just thinking 4.08. 4.08. 4.08 would be 140. And then half. It's going to be over 140. What does it come out to be?
1836.
Oh, 1836. I ain't even doing it right. Okay, that's fucked. 1800 and what? Hubert's not a doctor, okay? 1836. I was trying to do it in my head. That's what happens when you try to do it in your head. So 1836. Let's see what they got. Now we might have rounded, but I don't care. If you do it on your calculator, you'll be all right. Because that's what most of y'all are going to do. 1836. Let's see what they got. Where is my problem? Is it on here? There it is. 1836. It's a miracle. All right. So make sure you can do, when y'all go home and work on homework tonight, make sure y'all go work on 8.1 through 8.4. Because, and I'm going to be very lenient. If y'all come back with a bunch of questions Wednesday, we'll go over whatever y'all want to go over. But you need to work on it. Because if I don't have any questions, what does that mean? I'm going to assume